So we'll start with this. What do we got? Missing one. So this is the answer sheet you're going to have tomorrow. So for the exam, so it's a big sheet, 11 by 17. We're going to ask you to answer column A. Answering column A is worth 3 points. B and C, you'll pick one. So what is the category or what is the purpose or reason for feeding this feed? And then I'm going to ask you to pick 2 out of the 3 on the end. So NDF, protein, or energy, give me a high, medium, or low. So you're only filling out 6 columns, or no, 4 columns out of the 6. Yes.
Now, if we answer them all, do you take the correct ones?
No.
Oh, okay.
I'll take the first 2 I come to.
Okay.
So I would put an X in the ones that you don't want to answer, but that's not necessary. So yes, if they're both answered, I will go the first one I come to, and that's the one I'll grade. So working left to right, as we do usually in the USA. So you've got 50 feeds that you're going to be working. We're going to be in the 4 tomorrow. So, So lecture 19. So feed ID, we'll have 2 videos I want you to take a look at between now and the following week. You can either pick up the assignment at the exam, we'll have a worksheet there, or you'll be able to download it off of Blackboard, however approach you want. The links will be up on Blackboard. You're going to listen to Professor Hutchins from the University of Illinois talk about dry matter intake, and some people from Pro Dairy talking about silage and how you actually evaluate it. This is in the context of the Dairy Challenge, how you evaluate a forage program, silo management on a farm. So what do we got? 2 weeks from today is the next exam, and it'll cover through Monday's lecture. So we'll be into minerals fairly deep as we go through. So we're going to talk about minerals today. You got your feed ID tomorrow. Minerals will take us probably till next Wednesday. Lactating cow rations for a couple weeks. Then we'll go into a more automated approach to ration balancing, when we'll balance for 8 nutrients instead of 3. We've got vitamins and feeding cows, and possibly somewhere along the way we'll talk about balancing rations for heifers. Lab practical last Thursday of the calendar year. Exam 3 will be during finals week. So set for tomorrow. So we'll get your buckets out today. Get everything there. So practical, we talked about that already. Here's the schedule I've given to Professor Marshall. So everybody where they want to be. So lab practical there. So review sessions, Mondays, any other day that is possible. So right now, the only Monday I have available is the one right before the exam. Is that enough, or do we need to back up a little bit? Does anybody want review sessions? Okay, that Monday is enough, or do we need another one? Probably 7 to 9 again. Is that work for everybody who wants one? Okay, so what is that? 9th is Wednesday, it'd be the 7th. So we'll get that posted. So minerals. Got some handout here to help you move through. Is it worth getting these handouts or not?
Yeah.
Okay, does anybody know anything about minerals? We know, anything? Rocks, yep. They can be natural. They could be inorganic or they could be organic. When we're talking about minerals, and the companies that sell you the organic ones claim that they are more bioavailable. Hopefully by the end of this, you'll understand what that means. Anybody know what probably the most common, for lack of a better word, metal is on the planet, or mineral? Silicon. So it's most of the Earth's crust. So got an iron core supposedly in the center. I don't know how many who got there and looked, but certainly in the movies I've seen recently, they have some other ideas of what's in the center of the Earth. So minerals, inorganic elements. So we're not talking about carbon atoms anymore. There's no carbons involved. So usually these are single atoms. They may or may not have a charge associated with them. And they usually have to be broken down into that individual atom or ion to be absorbed. So one of the important things or misconceptions that we've had in the past, so I say this up front, cannot be created or destroyed in the body. Protein can be made, carbohydrates can be made, fats can be made, vitamins may be even made in the body, but minerals have to be supplied. Does anybody know the only place where minerals are created, or the places where minerals are created? Center of a star. Hydrogen is compressed into increasingly more complicated atoms. You also may have some creation in a nuclear reactor. But so everything has to be fed. Nothing is changed in the rumen. Everything needs to be broken down into that individual atom or ion to be absorbed. So they provide no energy. They are structural elements. They are catalysts in some way, but they are not broken down into energy. If we were to extract the energy from one of these atoms, what would happen? Nuclear explosion. So that's not the direction we want to go. So functions. Structure is the one that comes to mind fastest. So we talk about calcium, phosphorus, magnesium, possibly chloride, all as the hardness that we associate with the bones and the teeth. So the volume is made up of protein, that way gets laid down first. Then they put in the calcium, phosphorus, possibly magnesium, possibly fluoride, possibly chloride, to make it hard. Has anybody ever seen that demonstration where you take a chicken bone and you soak it in vinegar for a while and it gets bendy? If you can extract the calcium from that bone, all that's left is protein and it becomes as rigid as a steak. So that provides that rigidity. Acid-base balance in the fluids of the body. Here we're talking mostly about the electrolytes. Sodium, potassium, and chloride are going to The balance between the positive charges and the negative charges is going to determine whether it's acid or base. The more negative we have, the more acidic things are. The more positive charges, the more basic it is. We have a balance pretty close to even. That usually takes us to a neutral pH of 7 or close to it. Osmotic pressure. So one of the things about the electrolytes, they have a charge that gives us the acid base. They also, their presence helps us determine the osmotic pressure of a fluid. Does anybody besides Blaine know what that means? Osmotic pressure. Anybody heard of that? The amount of stuff in solution is a measure of osmolality. Has anybody heard you stick your textbook under your pillow at night and you study that way? Osmosis, everything moves from a high to a low. High concentration of knowledge in the book, low concentration in your brain. Everything moves from a high to a low. So that movement is called osmotic pressure. Maintain the proper pH of your gastric juices. You're going to use chloride to generate the acid in the stomach. You're going to use sodium to generate the base in the small intestine. We've got signals in some way, shape, or form. Muscle contraction. We need magnesium, certainly helps, but we need calcium to make that happen. Central nervous system signals. Those are your electrolytes again that propagate those signals. You've got hormone signals, cascades that are tripped or started by a number of different minerals. They also have strong interactions with vitamins, particularly D and calcium have a huge interaction. So vitamin D and calcium. And then it appears vitamin E and selenium are almost interchangeable. They have the same function. If you don't have enough selenium, give them some vitamin E. Maybe it gets everything done, balanced out that way. So we're going through two classes of minerals here that I want you to remember. The first are called the macro minerals. We're looking at amounts that you could see. If you put a pile of what a cow needs in a day, put it on the desk here, you can see that pile from across the room. So we're thinking about grams, handfuls when it comes to calcium each day. Whole lot perhaps with potassium, especially in the hot weather. So we've got the 7 up there that are called the macro minerals. If you remember on the analysis sheet, those were the first 7 minerals listed, and they were listed as a percent of the dry matter because we need them in larger amounts. So I tend to remember them by grouping them. Calcium and phosphorus. Usually think about bones with those. Potassium, sodium, and chloride are electrolytes. That's my second group. And then sulfur and magnesium are my last 2 to round out the 7. So you need a large amount. The micro minerals, we're talking 1,000th of the needs related to the macro minerals. They're also called trace minerals. Now, sometimes people include all these, sometimes they won't. We certainly are going to balance or check for or make sure we take care of iron, zinc, iodine, selenium, copper, and cobalt. There's some arguments on the last 4. There's certainly been some demonstrations that they're required. It requires multiple generations of rats on a molybdenum-free diet or manganese-free diet to show things. Whether they're required or not, there are certainly papers out there that show it. Chromium was real hot for a while. Has anybody seen that in your cough drops? No? In your cough drops, it has to do, it's thought to help your immune system. So chromium, certainly when I was in grad school, that was a hot topic of the newness of that revelation in the scientific literature. There are a number of questionable minerals out there, and we won't be spending time on them, but there are people that on extended generations of purified diets, everything else is right, but this particular mineral, you have problems, and they attribute those problems to the absence of one of these. So showing that if you take it away, there are problems, so therefore it's needed. It's hard with ruminants to go 3 generations on a mineral purified diet. I worked with somebody who was doing pregnancy copper and iron amounts in pregnancy with sheep. Those sheep were not happy. They had no hay to chew on. They gave them all more than enough NDF as purified NDF, but it was all powder. So they were trying to chew on anything just to keep that need up, but they didn't have any scratch factor at all. So nickel, silicon, vanadium, arsenic, boron. There's people out there that may argue that maybe this species is that species. You need those. More often than not, just living, there's enough contamination in your life that you will get whatever little amount they're suggesting that you need. So it's going beyond macro or micro. You're talking micrograms. So again, we're cutting our requirements by 1,000. So we're 1,000,000 times lower than we are with the macro minerals. So when it comes to testing, we're going to focus on the micro and macro. We're not going to do the questionable. Does anybody have any objections to that? Do they really want the questionable or not? You're happy with that? Okay. So minerals for cattle. Let's take a look at things. So we have the fractions of interest. And how do we get those measured? So the first thing we start with is the individual minerals. And we can set atomic absorption or X-ray fractometry machine where we put together a solution of minerals. So usually we go through and we digest the feed in a graduated cylinder. It's called a hot flask. It's set to a certain amount. And then we measure the minerals that are in solution. You can set it up that it will read those minerals sequentially. It'll do sodium, potassium, chloride. Well, no, it won't do chloride. Chloride's a separate machine. But most of the macro minerals, except sulfur and chloride, the other 5, and then some of the micro minerals in succession. So what we're doing is we're measuring the absorption of light associated with that particular mineral. We excite that mineral chemically, and then we measure what light gets absorbed by that energy consumption. So you're looking at basically an acetylene torch. So at least the one I worked with, you had your oxygen tank and you had your acetylene tank, and you had to adjust it just like you do for welding or cutting to get that blue flame. When you move or put that liquid through, it changes color. The machine has an opportunity at different wavelengths to measure the different minerals. And then given the concentration on 100 mils, how much sample was there to begin with, you do the back calculations to figure out percentage of the dry matter. So what happens with these two systems, you have the sample, it's being siphoned up and going into the flame. There's a specific light source that passes through that flame. And what disappears is recorded. What wavelengths disappear are recorded by that detector. And then we correlate back against standards. How much disappearance equals how much percentage of the dry matter. So you've got that for all the individual minerals. As you'll see in a lot of the Police shows that you have to be looking and you have to have your machine calibrated for a specific mineral if you want to see that mineral. You have to find that wavelength and set the machine correctly if you want to measure gold that's being used to kill her husband. She's using gold instead of lead or something like that. So you have to calibrate. It's tedious, but fairly straightforward, very well established. The other is just a bulk minerals, an ash. We put that sample in an oven at 500 degrees Celsius, about 1,000 degrees Fahrenheit, short thereof, for 5 hours. What's left in the glass beaker at the end is considered pure minerals. All of the organic material has been burned, respired to CO2 and water, and should go up the chimney. All the nitrogen, all of the oxygen should leave that, and what we should have left is just minerals. So we could call that crude mineral as well as ash. So as a note, when you're doing an NIR will spit out numbers for minerals, but they are in no way at all valid. They're doing correlations with minerals in plant tissue. The carbohydrates, carbohydrates, vitamins, fat, protein move in a concerted, parallel, correlated manner. The minerals work independently. The NIR cannot see minerals, but it can give you a number. That number has no basis or no correlation to reality. It just says, okay, the last time we had a 12% crude protein sample, we got a 1% calcium. But that calcium can be anywhere from 3 to 0. It's not related there. So let's talk about the macro minerals first. So you should have a page for each of these. So what I'm going to do for each of the minerals is we'll give you the type of mineral it is, we'll give you the name of that mineral, and we'll give you the atomic or chemical symbol that appears in the chart, the periodic table. We'll talk about function and distribution, daily requirements for each of these feeds, sources, absorption, metabolism, and then what happens if we overdo it or underdo it. What are our deficiency signs? What are our toxicity signs associated with this particular mineral? So we'll start out with calcium. More often than not, with the possible exception of potassium to lactating dairy cows, calcium is needed in the most abundance to get our animals growing fast and tall and strong. If you're looking at where you're going to find that calcium in the body, 99% of the calcium is in the bones. So 1% is in the extracellular fluids, blood surrounding the cells, inside the cells. Most of it, 99% of it, is found in bones, and it's there to make sure that those bones remain rigid. So we stand up and stand up tall. Calcium is needed for muscle contractions. It's the trigger that allows muscle contractions to start. So if you got a cow with milk fever, she's basically, and she's down, she's got no more calcium in her muscles. It's all gone, or it's not strong enough to make her stand up. We need calcium to be present for contractions to happen. Enzyme activators and reactions. Inside the cell, calcium acts as a secondary messenger. So you're going to have a protein hormone coming to the outside of the cell. It's going to set up a trigger that releases calcium into the cell. That release will set a cascade of enzymes and actions in motion. You're also going to have some in blood and tissue fluids that are going to help with pH balance. Calcium occurs as a +2 two positive charges associated with it. So it's going to generate a basic solution if you just put it in there by itself. So it's going to counteract the chloride and other negative charges. So by definition, macro, we're measuring the requirement, probably got a handful per cow per day, grams or percentage of the diet by definition. Where do we get that calcium? Usually we bring in mineral supplements to get that done. If they're out in the wild, either the animals don't grow as big as our current dairy cows, so don't need as much, or they'll grow slower. If they don't grow as fast, they don't need as much calcium each day. But we're trying to get good growth rates, get them to milk as fast as we can. So providing that extra calcium is necessary. We also know that our legumes are a good source of calcium as well. So we'll put alfalfa there. We also might get it from clover, but to get a good alfalfa field, a good stand of alfalfa, we usually need a good limed field. So that lime gets absorbed by the alfalfa, and that in turn can nourish our cows. So what are we going to run into? What problems are we going to have? If we've got a shortage of calcium, we run into milk fever. So this is usually a short-term shortage where the output in the milk is greater than what's being brought into the blood, either from the bones or from the gut. So milk fever is a short-term calcium deficiency. If we have long-term calcium deficiency, we get poor growth. We're not getting the mineralization of the bones. They're not going to grow as fast. And if that continues, we'll run into a condition called rickets. Has anybody heard of rickets before? So what is rickets? Does anybody know? So you're not getting the calcification. As we said before, the bones, they lay down the protein first. If they have enough protein, don't get the calcium to get rigid bones, they tend to bow out. So our cows, our pigs, chickens, their legs tend to bow. So that's a way to get some sort of rigidity to them. But they can no longer hold the cow, the chicken, the pig upright, and we get a bow-legged approach. That's rickets. So we will get abnormal bones if we don't have enough calcium, and we will run into osteoporosis in later life. Or if we've got a situation like the farm one of our alums was on, the acid-base balance in the water was so messed up, it was pulling all the calcium from the bones to try to balance the acid in the water. And cows were getting osteoporosis, which is not something you normally see. So one of the things that we, or at least help me, and I'll give you this handout sometime next week, is trying to use pictures to help you remember what calcium is involved with. So in past years, we've asked people to contribute to these. So students at extra credit on the final, they can contribute a drawing about a mineral or a vitamin that helps. So we've got skeletons here. So calcium from milk is involved in the bones in the body. You might say calcium is also involved in contractions. So we've got the gun show going on. Calcium is necessary for that. We're doing some lifting. Need to drink that calcium to make sure that we can contract those muscles. So international boxer Float like a butterfly, sting like a bee. Does anybody know that phrase at all? What? Okay.
It says it differently.
Yes, he does. It's from Muhammad Ali back in his boxing days. That's how he described his boxing style. So we have a boxer here, making sure that he's got incredible teeth and muscles, not enhanced by steroids associated with the calcium. So somebody here getting milk fever and falling over. Hey, you need to get some calcium in you to get back up. So I eat before working out. Bones are so strong thanks to all this calcium. So some people get pretty detailed in their drawings. Some people have a gift for it. I don't judge it on neatness or style. It's just whether you do it or not. So whatever helps you remember is a good thing. Phosphorus. Second most abundant. We're working our way down from the amount that's needed. Phosphorus has got a few more functions than calcium, so not all of it is going to be found in the bones. So 80% in the bones and teeth is fairly typical. So we're usually looking at phosphate in the body, the phosphorus molecule with 4 oxygens attached to it. If it was pure phosphorus in the body, it would do bad things. So the phosphate is how it gets there. So it's involved in energy metabolism, ATP, ADP. We need that phosphate group to hold that high energy bond. If we don't have phosphorus, we don't have that phosphate, bad things are going to happen and we can't form that high energy bond that helps us out. Phosphorus is going to be an integral component of both protein and very much so DNA. DNA, RNA, it's part of the sides of the ladder. You've got the DNA helix, a twisted ladder. Every other component to the uprights on the side, it's sugar, phosphate, sugar, phosphate, sugar, phosphate going down. Then you have the nucleic bases going across as the rungs. Phospholipids, the fats that make up our cell membranes, have a phosphorus group in them. And we usually illustrate that by the lipid bilayer. You have it put together with a cartoon that looks like that. That's the phospholipid. And then you got whole bunches of them in a row that are going to form that bilayer. Has anybody seen something like this before in your biology classes? So phospholipid, this ball here is the phosphorus. Phosphate molecule attached to the rest is organic. The phosphate is likes water. The fatty acid tails do not, so it's self-organized. All the hydrophobic things group together, and then the phosphates face the water. Acid-base balance, it's a negative charge on that phosphate, so it's going to contribute to the acid load that you're going to find in your feeds. So again, macro mineral, grams or percent of the diet is how we measure that. I'm not going to ask you to remember specific requirements. So mineral supplements, we need to get those usually from some sort of guano, either current or historic pile is where this usually concentrates. So bats, birds, caves, that phosphorus is a pretty valuable resource, and we're assuming at some point we're going to run out of it. I'm not sure if oil is going to be first or phosphorus. So it tends to be found or pretty high in byproducts as well. So distillers grains, brewers grains, we seem to have higher phosphate amounts in those. And since usually phosphate is the thing that's driving our manure management program, we can only do so much phosphorus in a given year. Our ability to keep that phosphorus down and matching the needs has some real benefits as to how much manure we can put on a field. So oddly enough, if you feed to requirements, there's very little phosphorus excretion in the manure. It's when we went through a period in the late 80s, early 90s, well, at 3% or 0.3% of the diet dry matter as phosphorus is good, then 0.5 is better. And that turned out to be not the case. People were just selling more phosphorus. It's a very, very expensive because there's a number of different industries that are competing for that phosphorus. Calcium, what do we got? Cement companies, that's about it. But phosphorus has a number of different applications, gunpowder among them. So I want to try to get that balance right, get it where it needs to be. If there's a deficiency of phosphorus, you're going to have a rapid, unthrifty, inappetence, poor growth. Deficiency is rapid. So where do you think you're going to lose it first among these sources or uses? Probably going to lose it first related to energy metabolism. So that's why you get that unthriftiness, don't feel good, don't want to eat, kind of look to the cows that are not getting the phosphorus. So as you might imagine, if there's bones and teeth, you're going to have poor growth. Lactation and fertility is associated with poor phosphorus nutrition. We will get the rickets problem again. It's not as pronounced or as classic as it is with calcium. You're going to have a number of bone issues. And then you'll have something called pica. It's a depraved appetite. So the animals start chewing on things that they normally don't. Now, not every time they're chewing on something means that phosphorus is deficient, but pica is that deficiency. So we see it in cribbing in horses. We see it in dirt eating by some other animals. That's pica, depraved appetite, trying to get that phosphorus in some way, shape, or form. Now, just because they're chewing on the stalls doesn't mean they're phosphorus deficient. They all might be bored, or maybe they're stupid. So there are a number of different reasons that cribbing can occur. You need to sort that out. So that classic symptom of eating things that you might not or should not is associated with phosphorus. So phosphorus, I made sure I had my phosphorus today. So happy, chipper. We're not that unthrifty animal. So phosphorus in bones. This colored one didn't come through as well as it might have, but we're focusing on the 80% found in bones. So helping remember that. Phosphorus, good for the teeth. Running out of gas, losing their teeth. I don't have enough phosphorus in the body. to make a good show of it. So those are our phosphorus ones. So we'll stop with magnesium, bring those handouts. Next time, I've got a quick quiz for you. When you are done with the quiz, you are free to go. Any questions before I hand out the quiz?